Elementary Algebra, Final Assessment 4, Review, Questions 5 through 7, Outcome 2, Solving. In question number 5, we're given the instructions solve. When solving for a variable, we first begin by simplifying both sides of the equation. There are two parts to simplifying, the first being to clear any parentheses present. We see on the left side of our equation that we do have a parenthesis. We'll clear it by distributing the -4 through the parentheses. This means that we'll take the -4 to the x to create a -4x. We will then take the -4 to the 1 to create a -4 or -4. Everything else will carry down as is. So we'll have a -3x minus 2 on our right side, and carry down everything to the start that we didn't carry down. So carry down the 2x and the 7. So we have now 2x plus 7 minus 4x minus 4 equals -3x minus 2. The second part of simplifying is to combine like terms. Again, looking at the left side, we see we have some like terms. We have a 2x and a -4x. We'll combine these two because they are alike. They have the same variable raised to the same power. This creates a -2x. We will also combine the +7 to the -4 because they are also alike. So a 7 minus a 4 creates 3. So we'll write down here plus 3. On the other side of the equation, or the equal sign, we see that we have no like terms, so we'll just simply carry down the -3x minus 2. Once we have simplified both sides of the equation, we can now start to move values from left to right using the addition principle or the multiplication principle. What we'll do is first start by moving the constant 3 to the other side of the equal sign to move it away from that x. So we'll do this by subtracting a 3 off both sides, minus 3. When we do this, it leaves us with the -2x over here. The 3's have gone down to a 0. Carry down our equal sign, carry down a -3x on the left. A -2 added to a -3 creates a -5 or minus 5. Now we can move the x from the right side, the -3x, from the right over to the left. We'll do this by adding a 3x to both sides, plus 3x. A -2x plus a +3x is going to make a 1x, or just x. We don't need to carry down the 0 at this point. It's just holding a place. If you choose to, though, you can, just to see where that 3 went to. Now we'll carry down on the other side. We have the equal sign. A -3x plus a +3x cancels itself out and becomes a 0. We'll carry down our -5. So when we clean up both sides, what we see is that we have x equal to a -5. If we wanted to run a check to see if this is correct, we'd simply take the -5 and plug it back into the original equation wherever we see an x, then solve both sides of the equal sign. If it creates a true statement, then we found the correct answer. You should do this during the test as a check before submitting the exam. Question number 6 reads 3/4 x minus 9/10 equals 1/4 plus 2/5 x. The instructions read, use the multiplication principle of equality to eliminate the fractions or decimals, then solve. So before we continue with this problem, we're going to eliminate the fractions. We're going to do this by looking at the denominator's position or bottom position of each of our fractions present and find the lowest common denominator. okay, or the LCD, that number will then be multiplied to our fractions to clear them. So we see here that we have a 4, a 10, a 4, and a 5. The smallest number that all four of these numbers, or rather in this case 3 numbers since 4 is repeated, the smallest number that all 3 of these numbers will divide into evenly will be 20. So our lowest common denominator here will be a 20. So we'll come back here and multiply both sides of this equation by 20. So I'm going to take this side, multiply it by 20. So I'll just kind of put this 20 up out here. On the other side, I'll do the same. I'll multiply by a 20. By doing this, I'm taking the 20 and distributing it to the 3. So 20 times 3 creates a 60 over 4x. A 20 times a 9 creates a 180 over 10. A 20 to a 1 creates a 20 over 4, plus a 20 times a 2 creates a 40 over 5. Not forgetting to carry down my x. Now I can simplify this down. 4 goes into 60 15 times, so this is 15x. 10 goes into 180 18 times, so this is minus 18. 4 goes into 20 5 times, and 5 goes into 40 8 times, so this becomes 8x. I've now completed the first part of the instructions, which were use the multiplication principle of equality to eliminate the fractions. I can now proceed to solve the problem. I want to get my x to one side and my constants to the other. I'll start by looking at my constants and adding or subtracting as needed to move. Let's move the 18 to the right side. I do this by adding a positive 18 to both sides. When I carry everything down, I'm left with 15x. A negative 18 plus a positive 18 makes 0. Then I have an 18 plus a 5 to make a positive 23 plus 8x. I'll just carry down. Now I'll move the x to the other side. So I'll subtract this 8x off both sides. So minus 8x minus 8x. So when I come over here, I've got a 15x minus an 8x leaves me with a 7x. I already know that I've carried everything down and made this position where the 18s were 0. I'll carry down my 23, and a positive 8x minus a negative 8x, or positive 8x minus 8x creates 0. So now I'm left here with a 7x equals a 23. To get the x on its own, I'm going to divide out the 7 because it's currently multiplying to the x. So I'll divide both sides by 7. This clears my 7 here, leaving just an x. This leaves me with x equals a 23 over 7. Question number 7's instructions read simply to solve. When I look at the problem, I have x to the second power plus 3x minus 70. This is a trinomial. This trinomial will need to be solved by factoring. So I'll come in here and solve this problem by factoring. I see that I have a trinomial in the form ax to the second power plus bx minus c. So I will pull what's in my c position and what's in my b position to help me factor. What I see in my c position is a negative 70. What I see in my b position is a positive 3. I'll start by listing to find a set of numbers that when multiplied together create a negative 70, but when summed together create a positive 3. So I'll start with a 1 times a 70. I know this equals 70. Now, when I look back, I need a negative on this 70. So one of these two numbers will require a negative value. I'll need a positive, though, on my B position. So I want to make sure that as I'm going down the list, that my smaller numbers end up with a negative sign. So that when I sum, I'll end up with a positive value. So I'll put a negative on the 1. This creates a negative 70. When I look over here, a negative 1 plus a 70 is going to equal a positive 69. We would continue to list down. We would probably look to next at a negative 2, but we can already see that's going to be too big of a number. So maybe we'll skip down the list a little. This ends in a 0, so let's try a negative 5. A negative 5 times a 14 equals a negative 70. A negative 5 plus a 14 equals a 9. We're getting a little closer. Let's try, because it's 7, let's try here a negative 7. So a negative 7 times 10 would create a negative 70. A negative 7 plus 10 would equal 3. There are our numbers. We found the two numbers that we're looking for. So now we can write this as a factored number. Because when we look back up here, there was nothing in the A position, we know that our factored numbers are going to be x over here to something times x added or summed to something else. The reason we did this list was to find those numbers that need to plug in. This is going to be an x minus 7 and an x plus 10. Now we factored our trinomial. Next, we want to solve. We're going to solve by taking our two binomials that we found by factoring and setting them equal to 0. So we'll take the x minus 7 equals 0, but we'll also take the x plus 10 equals 0. On both of these, now we'll solve for x. Well, we get x on its own by moving the 7 away to the other side. We do this by adding a 7 to both sides. This causes this to come down to x plus 0 equals a positive 7, or x equals 7. We've solved this one. Now let's solve the second one. Let's subtract a 10 from both sides so that we isolate the x. We come down here, we have x plus 0 equals a negative 10. So x is equal to a negative 10. So our answers here are going to be 7 and negative 10.